Well, good afternoon, everyone. My name is Leanna Sweha, and I'm the Program Director for AgStart, streaming to you from beautiful Yolo County, California, right outside of Sacramento. We're delighted that you've joined us for today's National AgTech Forum webinar on robotics in agriculture. So without further ado, let's go ahead and launch right in. May I have the next slide, please? So a little bit about the National AgTech Forum. This is an event series by AgLaunch, AgStart, and NCBiotech. Late last year, our three programs decided to join forces for a virtual webinar and networking program. Stay tuned for future webinars throughout 2021, hosted by all three partners. And I'm excited to let you know that the next webinar will be held on Wednesday, February 17th. And the topic will be the CAT in the ag. And that will include CRISPR, Argus, and Talons. So may I have the next slide? On to today's content. I would like to first give you a short introduction to AgStart. And then I'll also be giving a short introduction to our topic of the day, ag robotics. So a little bit about AgStart. We are a nonprofit incubator for startups in the ag, food, and health space located in the Sacramento, California region. We offer education, mentoring, and connections to potential collaborators, customers, and investors. We also have a co-working space in Woodland, California, and we are right up the road from UC Davis, one of the premier ag universities in the world. May I have the next slide? Last fall, we announced a unique public-private collaboration to fund a new shared use incubator in Woodland for innovators and startups in the ag, food, and health space. Our new $1.5 million lab at AgStart is going to be a real game changer for the Sacramento region. The Yersha Day Hay Lab will be one of the largest state-of-the-art shared use wet labs for startups in the entire Sacramento Valley of California. We will also offer a certified food facility where innovators can develop new food products, ingredients, and recipes. We will also continue to have shared office space. Next slide, please. So a little bit about our topic of the day. So you may have read articles about how in the future robots are going to take over all of our jobs. Well, this may or may not be a sci-fi story, but let's look at some of the factors driving automation and robotics in agriculture. First, over the last 10 years, major advances in digital components like sensors, circuits, as well as networks like 5G, while at the same time costs have come way down. Second, the big issue of labor availability and rising costs. For example, in 2017, the Bureau of Labor Statistics predicted the number of agricultural workers in the United States to stay flat for the foreseeable future. And the cost of employing them continues to increase. For example, California recently enacted an agricultural worker overtime law. At the same time, the UN predicts the global population will rise to 9.6 billion or more by 2050. Automation and robotics, especially as part of a farm management platform with AI, can increase production while reducing risk of contamination and waste. And of course, the growing emphasis on sustainable and climate-friendly practices. And finally, we all know how the pandemic has disrupted ag and food supply chains. It has really shone a light on how we cannot neglect our ag and food supply chains, nor the safety of our ag and food workforce. The pandemic has simply put these issues at front and center. Next slide, please. There are so many applications for robotics along the entire value chain. For instance, self-driving tractors, drones, precision input applicators, then feeding and milking, particularly in dairy, weeding, pruning, harvesting, and sorting, processing, and packing, and the famous self-driving trucks. And there are big players and startups in each of these sectors. and in controlled environment agriculture, which is just booming right now, we are looking at completely automated production systems using robotics. And overlaid on all these spaces is artificial intelligence and its ability to take millions of data points from production systems and turn them into actionable knowledge. Next slide, please. So now it is my great pleasure to introduce today's guest entrepreneurs. Charlie Andersen is the founder and CEO of Burro. Charlie grew up on a working farm, obsessed with machinery and autonomy. After receiving an MBA from Harvard, he worked for CNHI, John Deere's largest competitor, where he spent time looking at autonomy companies from an acquisition perspective. That experience helped him realize that the only way to get into the ag autonomy space was to found an autonomy company. And our second guest, Kyle Cobb, the co-founder and CFO of Advanced Farm. Advanced Farm is a venture-backed startup based in Davis that is focused on robotic crop harvesting. At Advanced Farm, Kyle's reunited with a team that had great success in robotics with a company called Greenbotics. Greenbotics was a robotic solar panel cleaning company for utility-scale solar farms. It was purchased by SunPower in 2013. Kyle's worked in mergers and acquisitions at Bank of America and Pearson, and he has a BA in business econ and an MBA from UCLA Andersen School of Management, and he lives in the great city of Davis with his wife and 2 children. Next slide, please. And participating in our Q&A is our special guest, Tyler Schilling. Tyler is the former president of Schilling Robotics, a robotics company located in Davis, California. And we are really excited to have Tyler with us today as he brings a wealth of knowledge and experience in robotics in growing a successful robotics startup. So Charlie, the floor, or I guess I should say the screen, is yours.
You guys hear me and see me? Hopefully. 1 second.
You're good.
Sorry, guys. Give me 1 second. I hate doing this. Unmute. This happened exactly this time. Okay. I think I can share my screen, and I think I can show. Okay, and sorry, I'm still, sorry, can anybody hear me or not? The right as it handed over, it killed my audio.
You're good.
Okay, all right, so okay, so I have no, how did this do this? Okay. Headset, Bose. Okay, guys, I'm gonna do this with, I can't hear anybody, but I'm gonna present anyway, and then hopefully we'll fix it as we go through, if that's a reasonable plan.
Charlie, you're good, but can you go full screen with your presentation?
So our company's called Burro, and we see collaborative, we see people scale collaborative robots beginning in agriculture. And I'm going to just take a little bit of a second to kind of talk through my background and then how we came to be. And broadly speaking, this presentation is kind of in part pitching, but in broader part, kind of a narrative around the space. And so that is me there. I grew up on a working fruit and vegetable farm. And for me growing up, I loved farming because I loved the machinery and the tech at use within the space. And what I hated about it were all of the tasks where you had to get out of an air-conditioned tractor cab and go pick, prune, weed, spot spray, go do anything else by hand. And so I then got an MBA from Harvard, got out of business school, went to go work for this company, Case New Holland, which is John Deere's largest competitor. And there I spent a ton of time looking at autonomy companies from an acquisition perspective. And that experience led me to the conclusion that autonomy is a force for new market disruption within agriculture, which has a very particular meaning. What it means is that autonomy is creating these new markets that are underserved or even in many cases ignored by existing large incumbents and are therefore particularly ripe for startups to tackle. And you might ask why, like why would that actually be the case? There are two dominant root drivers for it. The first one is that today you have this perfect storm of technology advances. So suddenly computer vision is really cheap and becoming really, really good. And so in conjunction with low-cost cameras, GPUs, and then increasingly modular software and AI, suddenly you can build platforms that can navigate just about anywhere, can recognize pretty much anything provided they've seen it enough times, and then can also tackle some of the dexterity components. So ultimately, you actually replace people's hands a bit in certain contexts. And the second factor driving all of this is the labor dynamic. And so I think it was alluded to in some of the earlier discussions. I spent pretty much this entire year in the field with growers, last year in the field with growers. And last year you could have a crew work a 50-hour work week and you could pay them $13 an hour. This year it's going to $14 an hour and you can only work people a 45-hour work week, which is so that you have this 10% decrease basically each year in terms of labor availability, combined with a increase in cost per hour per person. And at the same time in this dynamic, I think when people think of autonomy in ag, they tend to have this view of somebody sitting in a tractor in the Midwest somewhere. And so they think corn, wheat, soybeans, those types of crops. And the reality is that while field crops are a huge market for the large existing incumbents, because they are already mechanized, there's very little opportunity to automate or take labor out of that space. And the reality is that 88% of the US crop workforce works in fruit, vegetable, and nursery crops, and their labor is about a quarter of revenue. And as you talk with growers, the number one challenge they face is labor. People are screaming for robots. And at the same time, because it's such a diverse segment, it's very difficult to build a autonomous platform or a robotic platform that has a large addressable market, because everything you build tends to be really particular to some specific use case. And so in all of this, I think what we know is that in 20 or so years, the most labor-intensive areas in this space will be automated. And what's very much unknown, and what I'm in the business of trying to figure out, is how do you win in the next 5 years? And we'll touch kind of briefly on what we're actually doing. And just before I do, I want to touch briefly on our team. Today, we're a team of 13. My co-founder, Terry, got his PhD in vision-based autonomy from Oxford and spent a couple years with another startup called Cozy, building robots that can navigate around grocery stores and scan the shelves to tell you what inventory was where, purely using computer vision. So that's kind of the skill set that we're applying to the space we're in now. And then I think what we have found is that to build these types of platforms or to build autonomous systems, you have to have a very large, multifaceted team with experience across hardware, software, data, AI, sales and support, and that's broadly speaking the team we've assembled. And the approach we're taking is seemingly obvious, but yet somewhat unique, almost in a surprising way. So instead of building a harvesting vehicle today, we're instead taking a stepped or a phased approach, beginning with people scale collaborative robots that help people work right now. And they are built in a way where they're very data acquisitive and can be modularly expanded as dexterity becomes more viable in the use case in which we work. And just to make that actually real, here's what one of these actually look like. Hopefully the video is coming through okay. These are, again, the robots are called Burros. and they're about 4 or 5 horsepower, and they run up and down rows autonomously and back and forth to central points so that people no longer have to do that. And as they are working in these environments, they are extremely data acquisitive. So each one processes about 1 terabyte of imagery per hour of runtime, much of which is fed online. And so, and then at the same time, to get something to work in this scenario, we've had to build autonomy in a very, very different way that we call pop-up autonomy. And so with pop-up autonomy, everybody in the field becomes a user, and you are training the robots over relatively short paths that then are retracing, leveraging an understanding of the world around them, and building into broader and broader autonomous progressions. And I think if you guys know farmers, farmers don't care about tech. What they care about is value creation. And so the initial value proposition that we bring is this, and that is that if you have a 6 or 8 person crew using a single one of these Burro robots, then those people can be upwards of 40 to 50% more productive, which basically offsets 1 to 2 people each day per robot, creating an enormous amount of value. And beyond this, I think the other exciting or interesting aspect of our particular approach is that we can work in crops that are fairly diverse. And so we are pretty much exclusively in table grape production today. We've also been in blueberries, blackberries, raspberries, nursery crops, actually been in solar farms, and just a whole kind of wealth of different use cases as well outside of this. But we're extremely focused on table grape production right now. And all table grapes in the US are grown in a couple counties in California. It's about $1.5 billion in revenue annually that flows to labor, so extremely labor intensive. And the impact of the minimum wage and overtime regulations in California are driving the industry to the point where it's only sustainable if it does adopt automation. And so into that, we are kind of racing into the marketplace. Last year, we had about 20 units running 6 days a week from May until right around Thanksgiving. We did about 7,500 autonomous hours, about 7,500 autonomous miles of operation over about 15,000 hours of use. And right now we are gearing up for the 2021 season. And it's looking like we'll have at least a couple of customers reordering something like 20 to 25 of these things. So our reorder board is growing. And I think when you think about an autonomy business going into agriculture, what matters ultimately is not your initial order, but rather your reorder. And so what enables us to get to the point today where people have tested our equipment and want to use it further is this approach that I have described a little bit called pop-up autonomy. And so with pop-up autonomy, we have something that can achieve a 99% degree of autonomy reliability and is built in a way where that works well enough to actually be used in a commercial format. And the more we run, the better we get. And beyond that, it's also so here is another example where as these things are used, they can go into all sorts of different, effectively you have a platform that can work in one use case like table grape production, but also if you put a hitch on it, you can go into a table grape nursery or an adjacent space. So the market for something like this is actually quite expansive, where we have this initial focus on movement autonomy in an initial area, but we're building a platform that is solving somewhat ubiquitous foundational things that are necessary for many other adjacent applications. And on that note, we've had a large number of other autonomy companies looking to buy our platform. And so we are planning to enable this as we grow. And we think that's one part of this space of kind of unlocking it, is having mobile autonomous platforms that have digital train tracks on farms to which other autonomy companies can bolt on dexterity and other capabilities. So with that, that is us. I'm hoping that that audio worked. I think I'm coming up on about 10 minutes. So I can, I guess, yeah, I think I can pass along to the next presenter, and hopefully that went through.
Well, thank you, Charlie. I just want to make sure you know that we could hear you. However, I think The audio might be better with your headset. So if you might want to try that again, I think that might work better. So thank you very much. And that was fascinating. I love the Burro. And Kyle, we're ready for your presentation when you're ready.
Right on. Hey, thanks a lot. And thanks, Charlie. That was fun. Really cool business you built. And I think you guys have done a really good job outlining a lot of the main issues that we're trying to address alongside companies like Burro and issues that are really important to face the industry. Thanks a lot to the AgStart team, to Michelle for setting us up today and hosting us. I'll spend the next few minutes just talking about our business and our product, and I'll also share a video so that you can see our product in action. So you've heard a little bit about this already from Leanna. We're based in Davis, California. We're focused on robotic crop harvesting. I'll get more into that in a minute. I'm one of 4 founders, and our path into agriculture was a little bit non-linear. I grew up with co-founder Mark Grossman up in Chico, California, just north of Sacramento. And then we joined up with his college buddies, Cedric and Carl, about 10, 12 years ago to start a business doing robotic solar panel cleaning around the same time that the utility scale solar projects were picking up and being built in some of the driest parts of the world where the sun is really strong, but also there's very little water and labor. So we learned a lot about building a business that was and deploying robots into really tough conditions all around the world. And there's a lot of parallels to what we're addressing today. We were acquired by one of our customers, SunPower, in 2013, and ended up sort of looking around and trying to solve the next problem. And being in Davis, which is one of the sort of the ag centers of the US, we were really inspired by a lot of the problems we saw in agriculture. Brought back some of our team from the previous startup and brought along a couple of really supportive investors along the way, which you see here, and have made a good way into solving this problem. Our mission is to automate some of farming's toughest tasks, to create a more efficient, humane, and data-driven supply chain for fresh produce. I think we've heard about some of the regulatory challenges, for example, labor minimum wage and overtime laws changing that have really put a lot of cost pressure on growers. And I think one of the other things that is always true about agriculture is it's just really tough work. Some of the things you see here, for example, sucking up bugs, bending over all day to harvest fruit, being in a field where there's chemicals being sprayed. I mean, these are all really tough jobs that frankly need to be automated. And so we're taking this really seriously and taking it to heart and trying to solve these problems one by one and really improve the quality of work in the field, make it a more sustainable job and sustainable industry. And one of the biggest markets for this is in robotic strawberry harvesting. So it's about $1 billion spent every year on labor for robotic harvesting just here in California. We have developed a product that we call the TX strawberry harvester. We're working with some of the leading growers, shippers in the industry. You see here on the bottom part of our screen, great partners to us. And I think what we've tried to do is build a system that really is scalable when it's in the field. So you'll see that there's no driver needed. It's an autonomously driven vehicle that harvests on its own once it's inside the block. We spent a lot of time looking at food safety, making sure that when we pick fruit, it's picked to the consumer's satisfaction and also in a safe way, day or night. And we have really put a lot of effort into designing this unit for scale manufacturing. And we have picked tens of thousands of pounds of berries for some of these customers you see here on the screen. And so there's a chance you've eaten a robotically picked strawberry sometime over the last 12 months. I thought I'd just take a minute and try to show a video of our harvester in action. And if in case it comes across choppy, John is going to share a link with you all in the chat window so that you can explore this on your own now or later. We can watch together. And what you'll see here is first just how our fleets are configured with one operator operating many machines at a time. And then you'll get a look under the hood and see how the picking process works. And finally, how we take the fruit out of the field and get it ready to be packed for a consumer. So this is how strawberries are grown in most of, in soil in California. And California represents about 90% of the market for fresh strawberries in the US. So we've tried to build our system in a way that adapts to the current farming system, which I think is an important distinction between how some others have tried to tackle this problem. What you'll see here is we're scanning for fruit, picking red fruit and leaving green fruit behind. Strawberries are sort of evergreen in the sense that they're always growing and always need to be harvested. Every couple of days, you're going through the same field and picking new strawberries off of the plant. And that is one of the reasons that it's really labor intensive, along with the fact that the fruit is really sensitive and really soft. And so you have to find a way to delicately handle the fruit. Those are all some of the challenges that we've had to deal with. And you'll see here, again, we're driving on our own and harvesting as we travel. And we can do this process day or night. And by extending that working hours on a farm, it really helps to sort of spread the load further and reduce the labor headcount required for harvest. So feel free to click the link if that didn't come through clearly for you. And just one last note, I think this is a really interesting area to work. We're a lot of my peers here on the engineering side are really talented, and we love building things. We're based in an old barn and a tomato farm just south of Davis in a suburb of Sacramento, about an hour east of San Francisco. It's a great place to work, and we're always looking for talented people to join us. These are some of our values that we try to focus on as we grow and represent every day in the field through our hard work with growers. If these look interesting to you and you think you've got skills and passion to help us grow in this industry, we'd really love to talk to you. So feel free to email me separately or check out our job descriptions on the website, and we'd love to have you.
Thanks, Kyle. That was fantastic. So interesting. I just love watching those robotic soft hands picking the strawberries. They're so gentle, probably more gentle than I would be.
Thank you.
So we're ready to move on to a discussion and Q&A. And just a reminder, I may have forgotten at the beginning of today to request that please post all of your questions to the Q&A. That way we can all see them and make sure that they've been answered. So it's my pleasure to bring back Tyler and Charlie. And Tyler, do you want to kick things off today?
Certainly. Glad to be a participant here today, and it's really exciting to see these two companies attacking these important but really difficult application areas. I wanted to start with a little bit of advice from my over 3 decades of work in what's probably a very similar space in terms of merging the need for software, electronics, and hardware development. I've gotten a lot of scars over almost 3.5 decades of development. And I think the two most important things that I've learned are, first and foremost, it's a reliability first situation for you guys. When you have a pioneering product, you tend to interact most with customers that are themselves pioneers. And unfortunately, one of the traits they bring with them is they like to participate in the development in one way or another. And one of the ways they tend to do it is by requesting additional features above and beyond what you already have designed into your product. And while they're a fabulous source of the emerging needs, you have to really resist that, because every single additional feature you add in competes with the reliability of the gear. And this is super important, because field failures when you're introducing a product like this have two really crucial crippling effects. The first one is they can steal the momentum that you're building for the adoption. And then secondly, they sap your team's resources because the urgency is so high to fix these reliability issues. And I would put a special emphasis on hardware reliability because it has a really crucial distinction from software reliability issues in that it can't be revised over the air. And this makes it a really challenging and costly problem, especially if your hardware is distributed eventually around the world. So anyway, reliability first. And then the second one, and I was told this really early in my career, and it actually took me probably 2 decades to actually adopt it, something I'm really embarrassed about. And that is that you should always take the approach that is called design for the test. And what that means is that you and your team have to have the discipline to figure out and elaborate what the tests are that your machine has to pass before it's done as your very first act. And then your engineering team simply has to design the machine to pass those tests. It's very difficult to do because designing tests is not nearly as fun as designing robots, but it will pay enormous dividends if you can come up with that that ability to design for the test to start with. Very difficult, took me 2 decades, but after we got rolling on it, life was much, much easier. So then I'd like to just have a couple of questions of my own for the 2 companies. And you can either provide an answer for both of them or the one that resonates most with you. And the first one is, what's the most significant problem you're currently facing, and how long in terms of calendar duration has it been a problem? That's the first question. And then the second question is the growth of your enterprise more gated by the availability of orders or your capacity to deliver?
Kyle, do you want to take a stab at that one first, or?
Yeah, sure. Tyler, I thought we agreed only softballs. Man, no. Thanks for the tough question. Okay, these are really heady questions. I'm going to kind of reference one of the things that you mentioned, Tyler, and that is that reliability is sort of the utmost importance when you're developing this type of tech. I think that I'd say most significant problem, it's always reliability when sending something out to tough conditions out in the field on a farm, an open land with on the California coast. It's beautiful, but it also gets windy and sandy and foggy and dusty, and there's like an endless supply of environmental conditions that I think we're up against. And it's always a battle because we always learn new conditions that we thought we'd designed around or that we thought we'd never encounter. And so I'd say that one is kind of always nagging us and probably always going to nag us. But I think the important part that I see about how we're approaching the problem is that we're out there every day and we're grinding through it. And I think perseverance is a great way to get past a lot of those things. And it's also something that growers really come to appreciate. So that's my answer to number one. And I think the availability and capacity to deliver, I think the availability of orders and capacity to deliver, I think that's sort of I think there's a balance there to find, and I think the balance is around really resisting the urge to respond to high demand. It's related to the first point about reliability. I think there's an endless amount of people who love robots and who love the value proposition and who can look through models and really believe the story. But I think that there are certain customers who are better early adopters of that technology. And I think it's also, you know, with limitless resources, deploying a bunch of equipment might sound like a good idea, but as a startup who's always trying to find that right balance of making progress before you raise more money and, you know, spending enough money to solve the problems that are in front of you, that's the kind of the never-ending question. But hope those are sufficient answers for you.
And so on my end, trying to deframe those questions, and hopefully the audio is okay. I apologize for the earlier issue. So the most significant problem we're facing, and how long has it been a problem? I feel like in autonomy in these spaces, hardware reliability, at least in our experience, has not been, that's been just we've had issues with it, but that has not been the hard thing. The hard thing has been the simple stuff an infant could get right, but that are particularly difficult to get a robot to do well each and every time. And so the example I would give would be something like localization. Where am I in the world, and how do I go from A to B, and do that repetitively under a canopy where the canopy blocks GPS. The scene looks different at 5:30 a.m., noon, and 4 p.m. And you have to nail that route all day long, and possibly into another day, without deviating a lot, because you're conveying something back to a central point that is right near people. And then you also have people working around you, and because you have people working around you, you've got all these objects that are moving around you that you have to behave well around. And so I think for us, the significant problem we're facing, and one that we are constantly up against and always solving, is just the seemingly basic one of where am I in the world, and how can I reliably run through that. And what we do with that issue is we track it on the basis of autonomous miles between faults, or autonomous miles between intervention, and everything that we do is oriented towards that KPI of having that trend, you know, upwards of 15 or 20 autonomous miles between faults. On the gated availability of orders or capacity delivered, the questions around scaling, I think you think about selling equipment to farmers, there are so many different ways that you can go into the marketplace. But no matter how you sell something, you have to get it to a user. You have to have it serviced and supported by a user, and you've got to be able to continuously upgrade that user into the newest stuff as you trade things out. And so I think most of these companies, certainly ourselves, we have done a lot of robots as a service, and then outright sales with a SaaS model. And scaling that early on is quite difficult when you don't have a distribution network. And so the way we have bypassed that to date is by only focusing on growers in California. But that means saying no to a lot of people in Australia and South America and Europe and other geographies. So it's almost like the fact that you are trying to sell directly and trying to scale directly prevents you from scaling into a lot of other geographies where your technology would be very attractive. So those would be my two answers to those comments.
So I wanted to ask Charlie the first question in our Q&A, which has been bumped up to the top, which means we're going to have you answer that one first. I think you have alluded to this, so let me go ahead and read it and see if you'd answered it or if you want to add to this. The scale of specialty crop production in California makes sense. What barriers, if any, are there for Burro to be successful in smaller scale specialty crop production on the East Coast?
Yeah, so I grew up on a 200-acre fruit and vegetable farm on the East Coast, and I think that I'm saying this as some. I would love if a robotics company came to me on my family farm and said, "Hey, we have a robot, we'll sell it to you at a great price." You know, like that. That would be awesome. I just think they're not good customers yet. They're not. You can't scale to little small farmers on the East Coast. And again, I'm saying this. I fit that description, but I don't think that's the best way to start a business today. Companies fail because they run out of money trying to cater towards customers that don't pay enough to justify the expense to do it. And so in our case, our customers are table grape growers within a 3 or 4 hour radius of Delano, California, which is where all table grapes are grown in California right now. And they typically hire 4,000 or 5,000 people per day to harvest fruit. And that's a great customer for me. The East Coast customer who has a couple acres of blueberries somewhere, that's a harder one to cater to. Some of the larger ones might be of interest, but we're not quite at a point yet where that makes a ton of sense.
Yeah. Well, thank you. Yeah, right. I mean, just the scale of production in California versus your smallest farms on the East Coast. I mean, it's something to behold. So thank you, Paul Olanch. I may have messed that up, but thank you, Paul, for that question. So the next question, and this one is for Kyle. And the question is, what distinguishes Advanced Farm Solution from other robotic strawberry harvesters, such as Traptic, Harvest Crew, etc.? And then how do you handle the packing of the strawberries?
Yeah, great question. Those are all great companies, great people, and working really hard to solve this problem. So I would say maybe I'll just speak more generically about what I see in terms of how people tackle these types of issues and how we're going about it. I think a lot of people a lot of teams when they go into any project, but let's just use strawberry harvesting to be specific to this question. They start to look at kind of off-the-shelf robotic components and try to make those work into this very specific application that has never been successfully addressed before with those components. And I think what we've seen where sometimes where teams can go wrong with that approach is one, those components are typically very expensive, which is not a natural match for agriculture, where fruits and vegetables are sold for low prices. And then secondly, when you take those off-the-shelf components and you try to fit them into these applications, they just don't work right. Either the ingress protection isn't right, or the shape and movement profiles of these robots aren't right. And so then the other thing that can happen, not necessarily related to that, is you think, oh, this problem could be really good if only the problem was a little bit different. Right, like if the plants were grown a little differently, or if the field was set up a little differently. And the problem with that is that you're trying to find a market for the solution, or you're even if that's the direction that things will ultimately end up at with respect to how the growing system will change over time. You're asking a lot of really early customers, and that's a hard thing to do in any environment, but especially in farming, where growers are naturally skeptical towards new technology. And so those are some pitfalls that I've seen companies take. And then how we're handling the packing of the fruit. We bulk harvest, as you saw with the video, that where we take the fruit in what's called an RPC, reusable plastic container. That's pretty standard convention in the industry. And then a human does what humans do really well, and that is pack it sort and pack the fruit in a way that's really attractive to the end consumer. So it's a better quality job that people can do in a controlled environment, sitting down instead of hunched over, and they can potentially even make more money in that role. So it's kind of we see it as a win-win.
So the next question is for both Charlie and Kyle. Have you had difficulty presenting your value proposition to farmers that don't necessarily have a labor shortage problem, to get them to start thinking about augmenting their workforce or pivoting long-term?
So I guess I can address this one first, Kyle, if that's okay. I think so if you're a grower today in California, and you're growing table grapes, you might sell a box of grapes for $20. That box of grapes, $10 of that box of grapes is flowing to your workforce. So the need for labor offset is so extreme. and there's so little availability of autonomy there that it almost becomes a question, why focus on anybody else? Because that's such a prevalent pain point right now. I think you will run into some autonomy companies that are looking to do things. An example would be they're trying to do things like autonomously harvest asparagus. Asparagus is no longer grown in the US, it's grown in like South America and places like that. That's a very difficult business to start because you go from $14 an hour to $300 a month. And so all of your economics change inordinately. And so I think to defray the question a bit more, I think the value of autonomy in ag today is best sold on the basis of labor offset. We will reach a point, I suspect, where you can start gearing more towards some other value propositions around the data component, understanding what's taking place at each plant, using herbicides and pesticides more efficiently. But I do believe that the pain point you're solving initially is labor with autonomy, in my opinion, if you're trying to build a business out of it today.
Yeah, I mostly agree with Charlie. I just have a couple of things to add, and they're maybe a bit contradictory to each other. So the first one is, I think this is actually like a perfectly reasonable sales filter to apply when you're looking at customers and trying to figure out which value propositions resonate with them. If you're not getting through to them, then maybe they're just not the right first customer for you. And there's a little bit of churn that naturally has to happen there. And then I think on the other hand, it's also really, it's always a really dangerous thing to get into an industry where you're competing, first of all, where you're competing with humans who are just amazing at so many things. And also where you're in a cost reduction conversation all the time. It's really, the best case scenario is sort of splitting the cost savings, and that means you're in a constant challenge to increase your own margins and lower your own costs. And like Charlie said, I think that's a necessary part of the kind of proving out your business case. But hopefully over time, there's certainly more to it, because it's a dangerous place to be.
Okay, so the next question is for Kyle. You said that the robotic machine learning was for outdoor farms. Has Advanced Farm done work inside indoor greenhouse style farms or vertical farms?
We're really focused on outdoor farms, like the ones you saw in our video. That's how 99% or more of the strawberries are grown in the U.S. And the U.S. trumps many of the other markets around the world. And so I think there's certainly a place for vertical farms in the food system. I'm not sure there's a clear place for them in strawberries yet, and in a lot of other crops. And so we are kind of like Charlie said, we're really focused on, what does it take to build a business over the next 5 years? And we wanted to go where the problem was today. And I think that problem is largely in soil.
Okay, so the next question is for both of you. Hello, how prevalent is the use of Lidar when it comes to supporting ag tech? Do you have any use cases that seem to be growing when it comes to survey, robotics, ag monitoring, etc.?
Why don't you go first, Charlie, if you've
a
response to this?
Yeah, I can do this. So I started pulling off robots, building them in the barn back in 2016. Early on, started with a SICTIM 561, which is like an outdoor 2D type LiDAR. I don't view LiDAR, I don't view LiDAR as, LiDAR is a great tool for certain jobs. It has not been a great tool for us with the job that we try to do. And so I think if you're a drone flying overhead, somebody like AgPoint, as an example, would be a company doing this, where you are covering a ton of distance and you can put a $40,000 or $80,000 LiDAR on something and produce some insights out of it. That is a great use for LiDAR. In our particular situation, my budget for cameras is $800. And so I can, I'm not going to put a $4,000 or $6,000 Velodyne puck or something on there. And if I need one, I actually need two, because I need them on both ends because the payload blocks them. And then separately, I get better localization and better fidelity and better quality with stereo cameras with color as well.
because that's broadly speaking how a human understands the world. And so you can start understanding crop around you, you can see color, you get depth as well at, I think, a higher fidelity than you might otherwise get if you had a 16 beam or 64 beam LiDAR in that particular use case. And again, I think all of this changes if you're a car moving at 70 miles an hour on the highway. We are a autonomous cart moving at 3 miles an hour right next to people. And so we don't need that kind of a sensor for our use case.
I think I'm going to use my one defer to Tyler card here. Tyler, do you have any interesting insights on this one? I figure you might, as it relates to sort of, component selection.
No, I actually don't. So
okay, so I wasted my card.
Who I defer to in these circumstances is Elon.
Yeah, I don't have much to add, Leanna, to be honest. I think Charlie had a really robust answer to that one.
Okay, well, the next question is from Connie Bowen. Hi, Connie. Great to see Burro's progress, Charlie. How, if at all, do you integrate farm labor contractors into your business model, distribution strategy, and perhaps relatedly, what are the main problems you run into today between people, users, and equipment?
Yeah, that's a good one. So I think there's beauty in selling a robot that is replacing people comprehensively because you don't have to deal with people in the environment. We are a collaborative robot. We're working right next to people. If you get into a typical farm labor crew, whether it be a contract labor crew or a set of employees with a grower, you have people ranging from an 18-year-old kid to somebody who's 70. You have people that are using flip phones, people that don't always read. Nobody speaks English in any of these fields. So if you can't speak Spanish, you have trouble with that. I think in our case, we have an interface in Spanish, and then we found it works best when we go into crews where you have a couple of people that become kind of leaders in the crew almost in terms of how stuff is adopted. And then our ground team speaks Spanish very fluently, and so it's very good at training people. And so typically, if you've trained people a little bit on how to use stuff, then they're good at kind of democratizing that understanding or sharing it with others. To the question, I think Connie's question specifically on farm labor contractors versus company crews, we have a slight preference for company crews. We found that if a customer owns their land or has land and then is employing the labor directly, they have a greater say in how stuff is used and can dictate more of how stuff is structured for optimal gains and use case. But that said, we've been in both and we've been fine in both as well. So hopefully that addresses the question to some extent. I think it's, if you're selling a collaborative robot, it's all about the people. So you got to get people loving the product, people using it right. You have to make it really, really simple. And to, I guess, Tyler's point about reliability, it's got to do the same thing every single time.
Right, yeah, it's all about making your job easier. So Paul Lynch, I hope I'm pronouncing your name correctly, is back with the earlier question, this time addressed to Kyle, comparing, contrasting California's large-scale specialty crop production to smaller-scale operations, and what your technology could be applicable.
Yeah, I think I'll just leave it pretty simply and just say that we've gone to where the market is today, and I think there are many steps that need to take place in order for a big part of strawberry production, the U.S.'s strawberry production, to go to another type of growing system. Lots of capital expenditures, lots of plant biology and genetics advancements that need to take place. And so I think that there's certainly many aspects of our technology that would be transferable, but I don't see us tackling those until the markets avail themselves, whenever that might be.
Okay, the next question is from Justin Ma at Bayer, and it's for both of you. Have either of you looked into opportunities for using your technology for research and development, whether it be in industry or academia, particularly for breeding and breeding trials?
I can go first on this one, Charlie, if that's all right. So I think breeding trials are like, it's kind of like a sterile environment in many cases, and that there's you know, you have to be really careful about the treatment of the early plants and the little plots that you have, so that you get really good data on the various markers that you're following. So we haven't directly worked in R&D with our robots for that reason. But I think what I would say is genetics and breeding is a sort of 5 to 10 to 15 year process. You know, by the time you down select and scale any variety that you think is really interesting. And I do think that there's some value in collaboration upstream, if you will, or across the system, where you know, right now we're going where the problem is, but in 5 to 10 years, you can't imagine a situation where you know, the tech has progressed a long ways, the grower has made slight changes over time that actually look quite different when you look 10 years ago into how the growing system was, and then the genetics have advanced and brought forward traits that make harvest, in this case, you know, much more straightforward. Mm-hmm. And so that's the extent of our you know, participation in R&D, but I do think it's important that at very least different parts of this system are talking to each other.
And so I think on mine, I'm not sure if I have a ton of comments on genetics. I think in our one of our largest customers runs a nursery, and so they're in grape production. They also have a nursery doing grape genetics, and so we're around like some of that thinking. I think in the case of grape production, there's not a lot of genetics you can do to make it all that more viable to harvest. I mean, there might be some tweaks you can do, less shatter, you know, getting fruit better exposed. But I don't know. I'm not sure that's the full nature of the question, but if that's where my thread, can you change genetics to make it more harvestable? You know, maybe. And then we certainly in our case, we have a lot of groups reach out about using robots to move up and down rows in different phenotyping things and things of that nature, but we haven't pursued that at all yet. So that's probably the extent of what I can comment on there.
Okay. So the next question is for both of you, and it's from Simon Tripp. Automation seems to favor large-scale operations that can afford the investment. Should we therefore anticipate that farm automation will accelerate the consolidation of smaller farms into larger operations?
Kyle, do you want to take this one first, or I can take a crack at it?
You know, why don't I say yes, but it's a longer time span than maybe you'd naturally think of. And you know, for example, if you're going to automate growing in an apple orchard, right? There's like a cycle of life, a life cycle of those plants or those trees before you would convince yourself to tear it down and start a trellis system that would be more accessible for harvest or something like that. So I think that it will happen. It will be part of the automation movement to see bigger farms that have the wherewithal to adapt to automation. But I think it's sort of a 10 to 20 year thing and there's there's a market plenty big enough in the meantime to before that trend takes shape.
Yeah. And so on my own, it seems like there's a consistent thread here about an interest in small farms, and then how does automation fit? I'm kind of seeing that thread in some of the questions. So average U.S. farm is about 440 acres, I believe. That's largely driven by some of the larger stuff in the Midwest. You start getting into a lot of specialty crop producers. Acreage, you have a small number of very large players and a large number of smaller players. And I think there's been a consistent trend over the past couple of decades towards consolidation throughout the space, regardless of the technology taking place. So within that, if you think about the impact of automation, if you're talking about, I guess it's very depending on space, but the impact of automation kind of implicitly with what we do in particular is a smaller scale modular platform that can stitch into one-to-one into a smaller operation. And also you could have more in a larger operation. And so I think selfishly, in the short term, because we're trying to build a business, you have to go after the large growers because they have capital to deploy and they can take risk without putting themselves at risk. Will that technology later be more accessible for smaller growers and make their model more tenable? I suspect yes, if they can sustain themselves and not be consolidated, between now and then.
Okay. So the next question is from Roger Kassenbaum, and it's for Charlie. The FAA requires licensed pilots to hold the controls, even if a drone is autonomous. Can a Burro operate on full auto mode?
Yeah, so I guess, so in response to that, we aren't a drone. We're not aerial. We're not in like FAA airspace. We're a ground vehicle that meets ANSI specs that have been written for this type of a platform. And then we are also about 300 pounds unloaded, about 800 pounds fully loaded, moving at 2 miles an hour, about a meter per second throughout the day, with safety lights, bumper bars, sound alerting users and so forth. There's a whole host of safety factors that have been applied that are identical to those that are applied in warehouse robots. And so if Amazon has thousands of warehouse robots in warehouses in California, our autonomy and robotic platform is doing exactly that same thing. It's just doing it outdoors. So I don't think that the analogy between a drone and the FAA has any application to us whatsoever. Now, there are some OSHA regulations that are specific to California that have been loosely drafted a couple of decades ago to prevent people from having somebody get off of a high clearance tractor towing a vegetable platform that people are picking on. And sometimes people perceive that that can prevent certain types of autonomy. We have not seen that apply to us. We have seen areas where that can apply to larger equipment in different use cases. So that might be the correct tack to that question, if you will.
Okay, well, I'm going to move into a different area, and that's raising money. There's a question from Patrick Moran asking if you both are raising capital. And then there's one specifically for Charlie. In your experience, has it been challenging raising money from VCs given Burro's narrowly focused market? And this questioner is assuming that VCs typically want to see large TAMs when deciding to invest.
Yeah, so on that question, I think it's one of the profound ironies of this sector is that so much, and Kyle, I'll try to not address this kind of at you guys specifically. I think one of the profound ironies of VC dollars flowing into ag autonomy is the notion that harvesting a particular type of crop is a massive TAM, and that building a platform that can be used in many different segments for autonomous movement is a small TAM. And so our vehicle is a people scale robot kind of akin to Disney's WALL-E that fits where people work and can work in a table grape operation, a blueberry operation, a nursery farm. We've actually had people from the solar industry ask about using them in other completely adjacent areas where you need same basic functionality to deliver. So my impression on the TAM side is that the TAM for our particular approach is actually pretty broad. And even if we're just in table grape production, you've got about $1.5 billion of labor in table grape production in California alone in a couple of counties. And we're offsetting about 40 to 50% of that with our device today if you adopt it in the right form. On the second question, raising money, certainly for us, we are going to be in the marketplace pretty soon, raising an A. We've only raised about $3.5 million to date, so pretty young, small, scrappy company. With that, we've been through 7 generations of autonomy. We've built about 40 robots. We have outsourced production at this point. I think we are set up pretty well for what I can see in terms of like the metrics you need to hit. I think my experience with raising money in particular, though, is that when you need it, you're not going to get it. When you need it, you're not going to get it. And when you don't need it, it kind of starts to find you. And so I think that as we have progressed, it has become progressively easier and easier to raise. And at the same time, it's kind of like winning an argument constantly. Oh, you'd never be able to build that, you build it. Oh, you'd never be able to sell it, you sell 20. Oh, so it's this kind of constant sequence of winning little things that people raise up as very valid critiques or concerns. And thus far, we've been successful, and I kind of anticipate that progressing, in the kind of going into the spring as we start raising.
You want me to
Kyle,
address
did
that
you?
one?
Yeah, please.
Yeah, you know, always happy to meet folks interested in the industry, investors, potential customers, people who, you know, just have good ideas. So I'm always open to introductions. And thanks for the question. I guess I agree with you, Charlie. I've never considered your addressable market to be very narrow. I've always thought it's pretty broad. So I concur with that.
Yeah, as a follow-up, Kyle, Ed Barnes is asking, you know, I believe that you said you're offering Harvest as a service, and do you see a time in the future when you will be selling your machines?
You know, the short answer is yes, but and right now we're not only doing Harvest as a service. I think there's several ways we work with our growers, but I can't exactly tell you when that is, and some of it is frankly due to advice from folks like Tyler, who built these big businesses and you know, had to explore various business models. And I think there's some value to sort of holding on to the ability to make continuous improvements on early generations of tech, and finding customers who are willing to, you know, be patient with you as you do that. And I think that's probably what we'll focus on for the next while.
And the next question is for both of you, and this is a California specific question. Do you think the California state government will provide incentives to your companies because you have electric powered systems?
I think so. Yeah, I think there's probably ability for growers to go after those types of probably more grower focused incentives to adopt, you know, clean air emission vehicles and things like that. And then there might be a pool of money available to companies developing those types of systems. So I think those are trends that startups should stay on top of, especially if the trends end up being, you know, firm regulations that guide the types of equipment that growers can buy, in which case, you know, you have to be prepared to flex your product requirement on the equipment manufacturing side so that you can meet those needs.
I guess I candidly, I don't really know if I have a very strong perspective on that. I think like in our particular use case, we use sealed lead acid batteries. Things go on a trailer at night. Like it just, we're so focused on cost and making something that is reliable and low cost and kind of delivers the autonomy that I think we have not as a team thought through, is there some rebate or a utility incentive or something in California that might pertain to us? So if there is, would love a heads up.
Yeah, of course. Okay, here's the question for Kyle from David Swintowski at Dunning Capital, congratulating you on your success in Village Capital and asking if you've managed planting strawberries at the beginning of the season or collected leaf samples for research.
Those are not applications we're currently focused on, but I do think that there is an opportunity to automate in some of the planting process. Again, it's also one of those tough tasks that is, you know, it requires really delicate human hands to transfer plants from a nursery into the ground, and it's been automated in some other crop areas, and I certainly think there's potential to do it in strawberries. But we have not spent time looking at that problem yet. And thanks.
Okay. And I believe you may have addressed this, but there's a question for both of you asking, you know, how much of your machine vision tech did you develop versus how much was an off-the-shelf solution?
Go ahead, Charlie.
Yeah, okay, Kyle, there might be some interplay between us, I guess, on this one. Like real senses and that, you know, that whole, like we did some back and forth on this. I think the reality is that you can take stuff off the shelf to some extent and get it to work. But if you do that, you have to customize things a fair amount.
to get them to run and handle the environment. And there's no silver bullet in this type of domain. From what I can see, it's a lot of lead ones, and they all add up, and everything is intertwined. And so we certainly have used off-the-shelf cameras. We use Intel CPUs. We're using NVIDIA GPUs, that sort of stuff. But that gets integrated tightly into a package where if you replace one thing, your GPS reception suddenly no longer works because it's disturbing something, or you're overheating in a certain use case, or you're pulling moisture in somehow. And so in short, I think that there's a broad integration piece, and then the separate part from a kind of an intellectual property perspective, or what are you building that's unique? I think a lot of it is also the data around what your vehicle or device encounters as it goes into the world. So if you want to know, can you drive over a tall weed, or do you need to stop for it, or can you drive through a puddle, or is it a really deep puddle you need to stop for on a farm? You need to see that scenario 8 or 10,000 times over 8 or 10,000 miles to have enough AI to train to understand it. And that, I think, is the special sauce in some of these approaches. And I think in Kyle's case, I'm sure that there's a large dexterity component, but we don't do it all. But in our case, it's broadly off-the-shelf stuff, customized, integrated together, and a strong level of data capture and proprietary software to make it all work.
Yeah, I think that's I mostly agree with that. I'll just add that, you know, I think maybe to say what I think this is kind of what Charlie's saying in a different way. You can get pretty far down the road on any one application or function with off-the-shelf components and pretty seamless integration. But at the end of the day, you know, it goes beyond that. You've got to innovate in some area that maybe isn't clear when you're first kind of de-risking some of the other aspects of the system. But I think in that phase of the integration for the computer vision or machine learning or whatever, that at that phase is when once you get past the integration and you're really trying to make it specific to your application and improve your performance, is when you've got to take ownership of the problem. And I think that manifests in a couple of different ways, almost always in software and data, like Charlie said, and then sometimes in hardware, where you decide to take on a really hard project to, you know, to improve your tech stack in some way.
So I have a question to you, kind of related to this past question, and it has to do with whether any of the data that you've been able to provide the growers you're working with have resulted in them perhaps changing any of what they do because you've been able to show them how they can be more efficient or effective or use their workforce better. Have you had that interaction with your growers?
I guess Kyle, yeah, I'll go first. I suspect mine will be a little bit less sophisticated, probably perhaps in yours. So we're right next to crop. We've got cameras mounted on the side, and you're a great grower. You have a 60-person crew with 6 or 8 units, and you need to decide oftentimes where do you actually deploy, where do you send those people, or which block do you send those people into to have them harvest stuff, and then also what are they going to pull out of it. And so one thing that we have developed is a cluster counting algorithm that tells you the number of pixels of grapes on vines, and it's relatively unsophisticated. We're not telling you the color of it or the precise number of grapes on each cluster, but that fairly simple information can actually be very actionable quite quickly. And so I hate the pun low-hanging fruit, but there is some relative low-hanging fruit if you get a robot into the field next to where people are working that is full of cameras. And then the other very basic thing we've done on the data side has been attaching scanners to equipment. And so as you have a robot moving through the field, today you just know, hey, I got 1,800 boxes of grapes out of this block. With a robot running with a scanner on board, you can actually tell the grower who picked what, where, at what point in the field, and how much was it, and which vines did it come from. And so that information there's no computer vision involved in that. It's just a scanner plugged into the side of something. It's got some lat long associated with an employee number, but that actually can become quite valuable if you hire 4,000 or 5,000 people a day.
and you want to see that information in real time throughout the day.
Yeah, I think one of the things that Charlie mentioned is actionable. I think that's the biggest, the toughest thing for a lot of startups in this space can have sensors or are getting more data than ever before. But I think there can be a risk of actually providing growers with another problem to solve in terms of having to figure out what to do with raw data or unsynthesized data that you give them in order to make a decision. So it's cool to hear an example, a really practical example that they have about improving the amount of actionable data that flows in the field. And I think for us, it's maybe the biggest conversations we have around data are one, the feedback loop that is required for any kind of R&D process. In our case, to improve ripeness mix, for example, because the strawberries have this feature where they go from green to red, making sure that we're always dialing that in. And then I think the second thing is doing things that humans haven't been able to do before, and like the harvest moves so fast and it's so dynamic with humans, and you've got these, like I said, these wild weather conditions. And so this might be more specific to strawberries, where the harvest kind of goes all year, but you're moving so fast in the field that the flow of information can't keep up, especially because it's done from human to human and not done in any kind of automated way. And so I think there's a chance as more automated equipment moves into the field to collect some of those insights and pull data together across the platforms to make sense of trends that we've never been able to see before. But I do think that that's more at scale, and it's not something that a lot of companies really need to worry about at the start of the company. And it's more important to get the data that you need for your R&D than to present customers with data beyond your core value proposition, in my opinion.
Okay, the next question is from Russell Morgan, and it is a COVID-related question, and he prefaces it by saying he realizes this is outside your specific area of expertise, and that it has to do with the protein subsector that, of course, we saw majorly disrupted from the pandemic. And there's an increased interest in robotics in that space. And how difficult do you see adoption of sensors, dexterity, et cetera, to the type of task in that sector?
I'm really sorry, Russell. I have no idea.
Charlie, any?
I might be in the same boat as just not knowing. And maybe this is really, but I think in robotics, it becomes so specific to kind of a use case or a domain, or where is the sun at a point in time as you think about a solution, just all of those basic questions become so important. And so hypothesizing about another domain that I don't know a whole lot about seems really risky.
All right, let's go back to your specific knowledge and expertise. So Kyle, here's a question from Chao Ming Lee asking about the firmness of the strawberry when picked by the machine.
Yeah, I think we deal with all the same problems humans have to deal with in this particular case, in the sense that, if humans have to be able to gauge the firmness and the ripeness and various other factors with the strawberries that they have to pick from the plant. It does make it difficult, I think. Looking back at some of the examples of where there's been some meeting in the middle. There's a great case study of UC Davis genetics programs developing a tomato that could be harvested by a automated tomato harvester, right? And it was firmer skin, more consistent shape. And this is, I think, back in the 60s or 70s. So, ideally there would be a single type of single shaped strawberry that, came ripe in 2 hours instead of over the course of several days, and was the same size and color anywhere you went. But that's not, there is more variety than that. And I think part of the challenge with dexterity and the end effector is having something that's flexible enough to, first of all, make those decisions. And then second of all, handle the fruit in a way that is gentle.
So the next question is from an anonymous attendee, and it's specifically addressed to Kyle, and it's asking if there are any other labor-saving tasks that your company is planning on tackling, or maybe other crops in the future other than strawberries.
Yeah, I mean, not to overblow the vision, but I think, you know, when we look at the 20th century tractor, you know, it was designed for 20th century problems, using 20th century technology. And I think Charlie talked about how there's been a lot of tech advancements that have enabled a lot of innovation in this area. And I think, you know, our goal is very much to build the 21st century farm equipment company, right? And I think that covers all kinds of applications and different types of problems. So I think there's a ton of opportunity to tackle other things besides the one that's right in front of us. But I do think that you know, it's important as a startup to keep that big vision in mind, and we let it inspire us, but also we are very focused on, we understand that the best way we can get credibility and resources to work towards those problems is to solve them sort of one at a time and do a really good job at it. So that's what we're focused on right now, is strawberry harvesting.
Great. So this is a question from Robert Sisson, and it could actually go to all three of you. Looking at autonomous field-based sensing applications that might have high value, or that do have high value to growers, and additional crops that could be next.
So high value sensing. So which crops next and high value sensing? I think on the sensing side, I feel like there's oftentimes people like dive into the sensor, so it's like Lidar, cameras, like they get very kind of into like the nuts and bolts of like what physical sensor are you putting on something. I think to me the profound thing that you have today is that if you get enough pixels, or if you see enough pixels of something, provided your exposure is fairly consistent, you can recognize almost anything with a pretty high degree of reliability. And so, and then that can be applied very, very universally in many areas. So any time we have a guy who's driving out to a field, getting out of a truck, walking up and down a couple of rows of some sort of crop and looking at them, and then on a note card somewhere, that can be automated in some form with where the technology is going. So just I get kind of caught on the sensing side. On the other crop side, I think that becomes kind of a function of like where is their demand, where is their labor, and then what is that labor doing, and can it be done mechanically, or does it have to be automated? And so I think in our case, we've been in table grape production, blueberry production, blackberry production, raspberry production, persimmons, stone fruit, nurseries, and all of those crops have very similar rows and layout and structure and so forth. And so if you can get autonomous movement into that space, then you have cameras in that space, then you're collecting data in that space, then you can understand what's taking place at the crop level in a way that's quite comparable to how a person might do it. So I don't know if that's addressing the question. I guess, Kyle, if you want to jump in, you might have some other thoughts.
You know, the only thing that I would add is I'll touch on that point about actionable data again, because I think that's an important thing to keep in mind. Kind of what you were saying, you know, get less hung up on the sensor technology and more about what questions it's answering. And you know, I think there's going back to another comment I made about the kind of the cost reduction game. I think sensors are maybe one area where you can actually add value. You know, you can find ways to collect information that people didn't know they needed, or that, you know, they can pass along to their customers and get a higher premium for, right? I don't know a perfect example off the top of my head, but you know, maybe this is a bad example, but that's fine. You know, you can help the grower determine that they used 20% of the pesticides of their neighbor, right? Because of some piece of information they didn't know they were having, and maybe they can pass that on to get a higher premium for their load of fruit or veg than their neighbor does. And finding ways to help growers secure those premiums, I think, are really challenging, but they're also really important. And I think you'll the ears will perk up from growers a whole lot faster if you demonstrate value in that way.
Yeah. Well, we're coming up to the end of our webinar. I wanted to give Tyler the chance to chime in if he had any more additional questions. We have one more question in the Q&A, but Tyler, was there anything else you wanted to ask?
Yeah, so I think my closing question to both of the entrepreneurs would be, what are kind of your wildest dreams about the future of your enterprises? You know, I in my early days, I always used to go to bed dreaming about what my my company would become, and I'd love to hear what your answers are.
All right, Charlie, you go first this time.
Yeah, so, and I guess this is probably the part of what we do that sounds crazy and very amateurish at some level. How does something akin to Disney's Wall-E start out? It doesn't start out as a motive being that travels around and knows everything around it, has dexterity and does everything. It starts as an autonomous cart that works next to where people work, and it's built in a very data acquisitive format. And over time, that gets expanded to do more and more things autonomously. And so I perceive that we are at a point in time where what took place in the PC sector in the 80s and 90s, standardization of form factors, universal operating systems that many people used, and then ecosystems built around it, will happen in the same space. And I think that there's an opportunity to build a people scale platform that is collaborative today, but over time becomes a standard onto which many other companies bring their autonomy, pull data off of, or sell through to other entities as well. So hopefully that captures kind of our broader vision or kind of where we see things going.
You know, Tyler, I think there's a couple of things that get me fired up. One is we've seen complete transformations of the ag industry in the past. Charlie talked about them a little bit in the Midwest, where we saw, you know, genetics in corn and the tomato example I gave earlier lead to more efficient farm equipment that then made a significant impact on the amount of labor that was used and really like drastically changed the cost structures of growing. I think we have the ability to do that in specialty crops. I think it would be really cool to look back on a legacy in 30 or 50 years and really see how what we're all working on today contributed to the transformation of growing systems and genetics and really like building a sustainable food system in the US using some of those ideas. And then, another one that I think is that I'm also pretty excited about is the ability to elevate the farm workforce. We've got some really good examples of robotic solar panel cleaning technicians, right? A job that didn't exist 20 years ago in the Central Valley of California, where people now have the ability to earn more money, have more comfortable jobs than they did before, while all those systems level kind of efficiencies were being worked out. And I think that there's a really cool chance to do that. And I'm excited for that as well.
Well, I think that's a really upbeat place to end our webinar. And just one message for everyone who's been asking about the slide decks. Our partners at NCBiotech said they'd be happy to post them on their calendar site. So I just wanted to confirm that with you all who've been asking. And I want to again thank our wonderful guests, Charlie, Kyle, and thank you, special guest, Tyler Schilling. And this has been a great hour and a half. Thank you for joining us again, and we look forward to seeing you at future webinars.
Thanks a lot, everyone. Thanks, Leanna.
Awesome.
Thanks,
Thank
Tyler.
you.
All right.
Really appreciate it.
Thank you.
Yeah, thanks.
Bye-bye now.